So as I usually like to do, I'll introduce with a song that will sort of reiterate the things we heard in today's keynote. Come gather us stations wherever you roam, and admit that our numbers have steadily grown. The community's awesome as saints set in stone. So if that to you is worth saving, then you better start teaming up instead of toiling alone, for the times they are a-changing. Come bloggers and writers who toot rise with your pens, and teach those new folks the chance won't come again. Where there once was a newbie, there soon will be 10. And your knowledge is what they are craving. Know that what you share with them is what you will gain, for the times they are a-changing. Researchers and coders, please heed the call. Without your effort, Rust would be nothing at all, and on safety would rise where it now meets its fall. May C++ proponents be raving. What divides them from us is but a Rust up install, for the times they are a-changing. Fellow moderators throughout the land, don't you dare censor what is not meant to offend. Otherwise, far too soon, helpful people be banned, and what's left will be angry folks raging. Our first order of business is to help understand that the times they are a-changing. The line it is drawn, the type it is cast. What debug runs slow, release will run fast, as the present now will later be past. And our values be rapidly fading, unless we find new people who can make them last, for the times they are a-changing. Thank you. So, easy mode Rust. So I hope that most of you are here because they thought, well, easy mode Rust, that's cool. I think Rust is pretty cool, but I really don't want to learn all that deep stuff. I mean, who here already knows Rust very well? Well, you're in the wrong talk, but anyway, you can, you can stay here. I won't push you out. Well, that's one thing, yeah. But again, this is about how can we teach as little Rust as possible to still make people productive. So you can still pass it on and teach people a small subset of Rust and make them productive with it so they can already do some cool things while learning the rest. So first, some ground rules. We want a really small subset of the language to learn. So we don't want to learn all this high and deep and whatever concepts. And yeah, this means we will have to make some trade-offs. For example, we may lose performance. Sometimes you have to use some of the deep concepts to eke out every last bit of performance you can get. We're not here for that, because if you're just learning out to do something, you want to be productive as fast as possible. You're not there to win some benchmarks or so. We obviously may end up with more lines of code, because if you're not using all those abstractions, then that's where you'll end up, probably. Oops, that was one too far. And we don't strive for good looks. It's not that we want to write that code that will pass a review from seasoned rustaceans with flying flags, and it's just to get the job done. So we want code that does something useful without learning too much stuff. So now, what are the hard parts that we want to avoid? Oops, let me check that real quick. That's better. So this is the first thing that people run into when they want to write Rust. And I've only picked one example that I have run into in the past, but your example might look different. But mostly it's you have some sharing and some mutation in that code. So you're looking at your items while you're adding to them. So that's obviously not going to fly. Well, let's try to compile that. Oh, that's unfortunate. And not just because I named the crate unfortunate. Of course, the borrow checker is having none of that, which is quite all right. I mean, the rules are there for a good reason. But now, well, we have a problem. We don't want to learn all that stuff. So if we run into that, we want to have a very quick fix so that we can not learn how borrowing rules work and just get on with our life. And the nice thing is we have one immutable borrow and we have one mutable borrow. So perhaps that lets us do something that will fix it easily. Well, there is one thing. We can simply clone our items while iterating over them. And so we will mutate the uncloned items while iterating over the clone. And as such, the link is broken there, so we're iterating one thing while modifying another, so the borrow checker will say, oh, it's all right, go on. Now, some of you may say, well, but all this cloning, it takes so much memory, and I really don't want to do this. This looks awful. Well, I say, first, we're not here for performance or for conserving memory, so please go away. No, just kidding. But in very many cases, the memory is really not an issue. Really. But if you really must have a way to do that without the cloning, there is another alternative in that you can simply index instead of iterating over the collection itself, because the index is something, it's just a range, it's just a number there, and you don't borrow until you're inside the loop. There are a few wrinkles here. One thing is that this if predicate is just an if, not an if-let. Because unlike if-let will borrow into the scrutiny, so the items of I here, which would mean that the borrow checker will still complain if you would do that. And also, well, the predicate will have already been run when the then clause of the if is reached. So the modify just modifies this items of I once, and it creates a new item, so it doesn't modify it in place. And then you can push because you no longer borrow items at that point. However, be advised that this is a bit more tricky. It can still fall afoul of the borrow checker, so I wouldn't recommend it. I would recommend to just clone and be done with it. Similarly, if you have data structures that you don't want to borrow in data structures, really. Just have plain values without ampersand stuff. That's also for another reason, to which I will come later. So the next thing that I want to talk to get it out of the way is macros. Of course, calling macros is totally okay as long as you understand what they do. I mean, if you don't, then, well, it's going to be hard anyway, and you have to look into what have you done. Oh, no, that's not what you want. But for example, it will be very, very hard to print something on the console without calling the println macro. So it's totally okay to learn that. Just look at its documentation. It's very thorough, it's pretty good, and it's easy enough to learn, although it's surprisingly complex inside, but let's not go there today, because we don't want to learn this today. We want to learn how to avoid to learn this today. And of course, you don't want to write your own macros, because then you'd have to learn a whole macro language to do that. So we're not here for that. You can learn that later. And if you're really curious, then you can do it right now, of course. But again, we want to be productive first and then learn the rest later. So with some code examples here, we shouldn't write a macro to just remove some code duplication. So if we only have 2 variants here, just copy and paste. It's okay. It's not that much. Yes, you will run the risk that the copy and pasted code gets out of sync. True. But with 2 or 3 instances, I think it should be manageable. And yes, this is a somewhat contrived example, but I wanted to fit on the slide. And yeah, so now some of you might think, what if I not only have 2 or 3 instances of that code, but say 10 or 12 or 100? Why? Then you can simply write code that writes code. This is not a macro. It's a plain Rust function that creates a string with the source code that you would have written. So you only use the normal Rust that you already hopefully know, or that you are ready to learn, because, well, at some point, a few things you will have to learn, and you just create that code from within Rust. No big deal. And yes, I've kept my contrived example, but yeah, in this case, you give the names as an argument, so you can have hundreds of names there, and you will end up with the code that you would have ended up with if you'd just copied it and pasted it 100 times. Now you might say, well, that's all nice, and I like this idea, but what if the names could change and I need to update the code ever so often? Wouldn't I have then to run that each time I need to change something? And what if I forget running it? Then the code will get out of sync with the list of names and all hell will break loose, my code will be wrong, this is nothing I want to do. So do I now have to write a macro? Well, no, you can just write a test. In this case, the idea here is that you have another plain Rust method that reads the code as it is currently. Then you create the code. Okay, now we only have 2 names here because 100 wouldn't have fit on the slide, but yeah. And then you check if it's still the same. If it is the same, then you're finished. You don't have to do anything. But if it's not the same, then you can just rewrite the code. You can change the code, update it, and panic so that whoever ran the test knows they need to commit the changes. Pardon. I got this technique from a blog post from Alexei Kladov. So to reiterate, ignore macros for now. If you can copy the code, if that's enough, just do it. if you need to generate code, just generate it from plain Rust code. And if you need to keep it updated, use a test for that. Because you'll want to be able to write tests anyway. So this is something you should have learned. And it's not that hard. You just push a test annotation on a function, and there you are. Also, I noticed that I've called a macro in there, the panic macro. But you should already know that. You can call it as you would call a function, and it will just crash your code with a suitable message. Now, traits. Traits are crazy powerful. And really, you can do a whole lot of stuff with traits. But they're also kind of complex. So of course, we want to avoid that if possible at all. At some points, you might need to have a trait for something. For example, if you have a type that you need cloned at some point, then you can derive clone on your type. That's easy enough. That's one small thing to learn. It's not that complicated. The clone implementation will be automatically generated for you. So that's not that complex. But this is for traits that are general and that are common. Not all traits can be generated, but if they can, it's a very good solution to do. Now, you might also use traits to disambiguate some cases. And in that case, well, you can also just use a bag of if clauses and do this case disambiguation at runtime. Yes, it will cost performance. Yes, it won't be that nice as just have a trait dispatch, but it will be easier and you'll get the job done. Unfortunately, some frameworks force you to implement a trait. And yeah, in that case, there is no option then either to ditch the framework or to just do it. In that case, I would suggest if you have an IDE or some good editor with, say, Rust Analyzer or something, then you can use the IDE to generate at least a stub for the trait implementation, and then you just fill in the blanks. And you don't really need to know what it does then. Okay. Now, with traits, there comes another topic here, that is generics. So for example, if you have a struct that is implemented to be generic over some types, well, that's, or a function that is generic over some types, well, that's also quite a powerful idea, but on the other hand, it's interesting to learn about that, but we don't want to do that here for now. So we want to keep it very, very simple. And here the solution is also very simple. We just built a plain foo AB struct or a plain foo AB method for each AB combination we want to do. And again, you might have many, many AB combinations there, but this is just a case for our macro replacement. We can just generate those. Because if you would implement a generic method there, it would also be very similar for each type. So yeah, it should be a prime suspect for macro generation, or for code generation. Now, another thing that stumps many beginning Rustaceans, lifetimes. Oh my gosh, what are those ticks? And well, let's ignore that for now. We don't want to learn lifetimes. I mean, they're cool in that they let us express some things, but We're not here to make full use of the type system or write various high-level shenanigans. We're just here to get the job done. So if we really need something that has one single identity and doesn't change upon cloning or upon copying, then we can just use an arc instead of a reference there. And yes, this will have a runtime cost. So you need to clone an arc to reuse it. And yes, that will update the reference count, so your code will be slightly slower. Also, the second thing is, what arc does is basically move the borrow checking to runtime, so you might run into runtime errors that would simply be compile time errors with references. But as long as you keep the stuff simple, and again, we've just learned a few lines of Rust, so we're not into deeply complex stuff. So we'll keep it simple. It will usually work. And again, even if you don't use arc, you can, for some simple things, you can just use the plain types themselves without references and just clone it if you don't care about the identity of the objects. If, of course, you want to mutate things and be sure that it hasn't been copied in the meantime, then you need to do things like an arc. So that's already gotten rid of a lot of things that people struggle with. Still, well, I could end the talk now, and this would have been a very, very short talk, but I still have a few things. But it's short. So unless you do embedded development, you won't need any unsafe. In, I think, at least 90%, perhaps more, of cases, you will get very acceptable performance with safe code, and there's literally nothing you cannot do with safe Rust. Really, literally, unless you are on embedded and don't have full platform support. Usually, everything you want to do is possible with safe Rust, period. So, no unsafe here. Same thing for SIMD. Hey, we're not for performance here. So let's ignore that. Why did I add that here? Well, forget that you saw that. It's not a part of Rust you want to learn right now. So we have no generics, so we don't have higher kind of types. Now for the elephant in the room. Again, like other things on this list, async Rust is really, really powerful. But we're not after powerful. We're after simple here. So avoid if possible. However, if you cannot avoid it, because sometimes you really want to use some crates or some frameworks that require you to use async. For example, if you use Exim or Actix or any of the web frameworks that are so common today, you will have to write async functions. So sometimes you will need to write async code. Unfortunately, we cannot completely avoid that. So if you can avoid that, if your dependencies don't ask you to write async code, just don't. Just write plain Rust code, it'll be fine. But if you want to do something where you need to write async code, then you just relax. You prepend async before your function signature. And whenever you have a function call in your code, you just append a wait on it. So that's even if you know that the function call will probably not be async function, just await it and let the compiler deal with it. So if the compiler tells you, well, this is not a future, you cannot await it, then you remove the await. But just by default, just await everything and let the compiler sort it out, because it's easier this way than the other way. So if you fail to await every function call, then you might have the chance where you call this function, but all it does is return the future to you and you do nothing with it. And that's something that's not that easy to debug. It will nowadays get you a warning that you should do something with that future, but even then we would need to learn more about async than we want to know right now. And so this way is certainly easier. So rather than letting the compiler tell us, oh, you need to await this, just await and then remove the await if the compiler tells you not to do it. Also, one thing that people run into, and I ran into that last week, and I'm not a newbie in Rust, but well, sometimes it happens. If you have some things that block, like a mutex, an RW lock, or conva, or whatever that might lock, be aware that blocking something within a task, within an async task, will block the whole thread. So this is something that can very, very easily deadlock, even if you're not intent to do that. So in async Rust, we must rid ourselves of the notion that our code runs sequentially, or you know where it starts and where it ends. It may run whenever. So avoid blocking things. If you really must have some synchronization, then use the synchronization primitives of the async runtime. Most runtimes have things like mutexes, channels, stuff like that. So use them if you really must. Otherwise, try to avoid synchronization if possible. That's another thing that trips people up. Modules and imports. So what I've seen is, and I've slightly exaggerated this, having one very, very large file and you can no longer navigate in it, and this is not tractable. I mean, I cannot navigate in a 20K lines file, let alone 100K, and yeah, so how would I find anything there? I mean, yeah. Perhaps with some machine learning or so. I'm not sure. Or the other thing is you get 10,000 files that are just a few things and they're deeply nested, and then you get lost in its structure, and at the worst case, some of those files are named the same, and then you have all those .modrss in your path, and your editor tabs are open with, oh, you don't know what is what. So let's avoid that. And again, we don't want to learn how modules and imports work. I mean, at some place we want to learn a bit of it, but we want to keep it simple. And the big problem is that modules and imports, they conflate the code organization with a path hierarchy. So you have paths in your code. Those are built by the crate and the nested modules and whatever items are in there. And you want to organize your code into different files so they don't get too big. But yeah, if you just split them up, then the items will have been moved within the path hierarchy. So let's split those two things. This means that when you change your code, you will have to do multiple steps at once, but that way you cannot run into the problem that, okay, I moved code, now my users can no longer compile because the code has moved. So for my example, I have these two things. I want to split the code without splitting the paths. So that would be the first thing. So for my example here, I have two methods that are very long, so they could fit on the slide. In practice, those could be 1,000 lines long each, or you could have multiple methods, but I'll keep it simple for the explanation here. So the first operation is we want to split this. We want to put, say, B into a b.rs file, into a submodule, and import it from the librs, but in a way that someone using our crate will still see the A and the B on the librs, so on the crate root. And so we can do exactly this. We have moved B into our BRS and replaced it in librs with a mod B and a pub use B : B. So we forward the visibility. Within B RS, the function is public. Otherwise, we couldn't pub use it. So the function and the use must have the same visibility. And I would suggest you only use pub or nothing, because again, we want to keep it simple. No weird qualifiers in there. And by doing this, from the outside, it looks exactly the same. We have a crate that has an A function, that has a B function, nothing else. And we have two files, so we can modify B to our heart's content without having to look at A and vice versa. Note that we don't make the B module public though, because otherwise we would have an A function, a B function, and a public B module that also contains the same B function. And now let's say the other thing, we now have split B off, and now we want to move it into a B submodule, actually, for our users. So this is a breaking change, but perhaps at some point our crate has grown unwieldy and we think we need to add a bit more structure in there, so we'll introduce that B submodule publicly. Luckily, we've already split the code in one way, and so we can easily do that. So we delete our pub use there, because the B function should no longer be in the crate root, it should be in the submodule. And now we make the submodule public, so it's now pub mod B instead of mod B. By doing this small change, for our users, we've used the B function from the crate root to the B submodule. And that's it. So those two changes are, well, I would hope to say, perhaps not very easy, but easy enough to not get wrong. And if you do it that way always, you'll never run into the problem that you inadvertently change the interface of your crate while moving code around. And you have a way of moving code around, of changing the interface if you want to. And of course, in this case now, callers will have to call B : B instead of B directly. Now, Rust is known as a very expressive language, so it has a lot of syntax. There are many languages that are easier from the syntax point of view, but you don't need to learn all of that. So mostly keep to if, for, and while, or perhaps whilelet. And the other things, if you need to use them, use sparingly. So match, again, like many things in Rust, is crazy powerful, but it's also harder to learn. So you can use it, but avoid the more complex things like pattern guards or nested patterns. Those are things you don't want to do, obviously. And one thing that I always get from people coming from languages like C or C++ is, Rust is so hard because try building a doubly linked list. You won't be able to do it. Well, I don't need to. I already have a doubly linked list in the standard library. So don't implement your own data structures. There's really no need to. You don't even need to learn all the data structures. So a simple thing is, if you have data that is continuous, like a list, you have 1, 2, 3, whatever, a number of items, then you use a vec. Simple as that. No need to learn all higher-end data structures like vecdeck, binary, whatever. No need. And also, even if you only have one element, you can still put it in a vec. Who cares? I mean, again, we're not after performance here. If you have a thing that looks like a dictionary or lookup, like something with a key and a value, so if your key is recursion, then the value is, please look at recursion. That's anyway. Then you use a hash map. Simple as that. Yes, there's a small caveat. If the type you want to have as a key doesn't implement hash, well, you might need to switch to a B-tree map then, but for 95 to 99% of cases, hash map will work fine, and let's not make it too complex here. Wow, this is also something that might come up. I want to return an iterator. No, you don't want to return an iterator. You just collect your things and you just return the collection. If you iterate into a serial collection of things, just return a vec. If you iterate into a key value pair of things, you might return a map instead. But if you really need to return an iterator, then you can box it like this. Yes, this is more complex, but you don't need to learn it. You just need to know that this line here, you have iterated something without collecting it. Just remove the collect there, and then you box it and return it as box of the iterator, and you need to specify the item type there. And there you are. But again, this is only as a last resort because let's say your iterator is not bounded, so it would collect forever and fill up all available memory. So just for those cases, you really need to not iterate right away. In that case, you can do that. And that's all. So, congratulations, you no longer have to learn Rust, but feel free to do it anyway.